In this module, you will be modeling and simulating continuous dynamic systems in Simulink. Dynamic systems are everywhere, and you interact with them every day. You can find multiple dynamic systems in a car, and even the car itself is a dynamic system. The circuits in your electronic devices are also dynamic systems. Even how global climate changes over time is a dynamic process. A dynamic system contains variables that change over time. There are three types of variables: the inputs, the outputs, and the internal states. An input is a stimulus to the system, and it causes other variables to change. An internal state is a system variable that evolves over time, and its value depends on the inputs, other internal states, and the properties of the system. An output is a result or value that's of interest to you, and similarly depends on the inputs, the internal states, and the system's properties. For example, let's look at your house's thermal system. The outdoor temperature is the input, and it causes an internal state, your room temperature, to change. How does that room temperature change? Well, that depends on the outdoor temperature, the room temperature itself, and your house's insulation. In this example, the output is the internal state, the room temperature, and it's obtained from its initial value and the integral of its derivative. In continuous time dynamic systems, we describe the rate of change of a state variable with its time derivative. Therefore, equations that describe continuous dynamic systems are differential equations, or they're state space representations. You can use Simulink to solve these equations and predict the system's behavior. In Simulink, a continuous state is obtained by numerically integrating its derivative in time. The continuous library contains blocks that support modeling continuous state systems. A fundamental block is the integrator block. Starting from an initial value you specify, it integrates the input signal to calculate the continuous state and returns the state as the block's output. There are general guidelines to solve ordinary differential equations in Simulink. To start, you need to arrange the equations such that the highest order state derivatives are on the left side of the equations, while all other terms are moved to the right side. Based on the equation order, you can determine the number of integrator blocks needed. Then you add the integrators to your Simulink model and label their inputs and outputs. Now you have all the continuous states and their derivatives. So you can construct the right-hand side of the equation by adding other blocks and connecting the signals. Complete the equations by connecting the right-hand sides to the left-hand sides. Finally, assign the state's initial values to the integrator blocks, and you're all set. You can also use Simulink to model dynamic systems described by their transfer functions or state space representations, as well as systems that have physical boundaries. Now, let's build some Simulink models to simulate continuous dynamic systems.